Morning, team. Welcome, welcome. Boo, boo, da, boo. Boom, 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 boom. But why would you choose the horse? Yeah, I'm a horse girl for sure. You know what they say about horse girls. Hey. That was terrible. I don't understand if that was a joke or not. Lenise, Ben, Daniel. Liam's here. Crystal's here. Zoe's here. But I'm too squared to say it. That's pretty freaking good. That's pretty good. Okay, sorry, who do I got here? Crystal told me she was here. Oops. David's here. Cam, I did not get a chance to see your TikTok yet. I tried to, but I can't play TikToks on School Talk or videos at all. Like, they just don't let me click them, so I have to download the video. But I thought that was a little weird if I downloaded a video, but I might have to do that to see them because they won't let me. It won't let me click them and play. It just like shows this like black box and the play button's broken. Who's got Wendy's here? Izzy's here. Huey, did I get Huey yet? How did you watch it, Yella? Did you have to download it? Ty, Batten, Bassett, Paul, Kyle, Josh, and Max, and Paula, unless she said something earlier. I don't see. Oh, there's Jerry. Never mind. No, Benny, I was being a little more quiet. Sorry. Do you need me to turn up my mic somehow? Was I just being weird? It's a math TikTok. Well, then I definitely have to download it. All right, let's see. Edsby. All right, Paul is here. Where is he? There he is. Good. All right, school, talk it up. See, this is what happens. Like, I can't click it. So I think I have to go, like, download somehow. Let's see how long that takes.
These ladies are hot. They're so very hot.
Let's see, I gotta show it over here. I'm confused with the audio so far, but
These ladies are hot. They're so very hot. So much stage to like so much queen niggas in they top.
I don't understand. What was that? Cameron, what the heck was that? Oh my goodness. Okay, now that I have it muted, how to fix your hairline in 3 easy steps. Now that Mr. Ellis is watching. Okay, I understand. Because it's like the clickbait, get me to watch. Yeah, good. Wow, that is terrifying. Thank you. Thank you. I love that you say this is Max's idea, so don't at me. Oh, frig, that was awesome. Thank you. Oh, boy. All right, who else is here? Cameron? Oh, that was good. All right. Who has come since then? So I've got Bassett now. I've got Max now. Ba-ba-da-ba. Freaking Cam, that was funny. Daffy is here. Batten's here. So just missing Kyle, Paula, and Ty, maybe? Give them no time. Let's just call it. There you go. You had your chance. Joshua's real birthday. Which Josh? Daffy or that grade 12 Deppy or whatever it is. Olajdi. I don't know how to say it. I also don't remember what it's spelled like, so I can't really pronounce it. I've never tried to pronounce it before. Josh O. How's that? Josh O or Josh Daffy? All right. That was a lot of something, Cam. I don't even know what to say about that. That was different. Daffy. Hey, Daffy. Happy birthday, bro. Oh, we didn't have class. Happy birthday, dude. I asked you guys, let me just actually remind myself what I asked you to do. Yesterday, we followed the semi-quasi Wednesday, take a review day because I figured you guys have been, some of you have been actually doing things, which I appreciated. So I asked you, there was a couple review questions that was like the mid-chapter review before we get to some harder stuff. Ty, you're going to have to message Mrs. Banta to let her know you're here. But anyways, there's all of these questions in here that I said take a look at if you think you need to practice up. But then the day before I said I also wanted to give you some extra time. So I did meet with some people yesterday. And we met and talked about, sorry, this is international business. Let's go to grade 11 math. We talked about these suckers in here. And I posted that video for you guys. I believe I posted it also in this page. Did I? Maybe not. I don't remember. Oh yeah, here's the answers to the questions right here. So that was me going through most of them. Now I didn't give you the answers for all of them. And I had no messages yesterday that I didn't answer, I believe. I think I got to all of you yesterday if you had any questions. So you should be pretty comfortable with that. The couple that I didn't give you an answer for were a little bit trickier, which is these two right here. And so I just wanted to talk about these two, the sine x equals -1 and the cos x equals 1 today. Now you actually may notice that I think it was back when we talked about special angles right here, right? I went through and I gave you this little trick where I said, remember sine is y, which we knew is sine is y over r, whatever, but in this case, r is 1, right? So there you got sine is y, cos is x, and tan is y over x. And so if I wanted to know, right, in this unit circle, remember we look around, so there's the x, y. You could have actually seen here, like if we're looking for sine is -1, you're looking for when is y equal to -1. So you could see here the answer would be at 270. But I kind of will explain that a little bit better in a second here. And we'll rock and roll from that. Holy smoke, sorry, my phone muted. All right, so let's go down and again, Kyle, you're gonna have to let Mrs. Banta know you're here. I've already submitted the attendance, buddy. All right, where is that? It's right here. Okay, so actually I'll do it on the answer key here so we can all see this together. So if you're looking at sine is -1, now normally, right, I would say draw out the cast rule. And you'd go here. How did I do this before? I might as well keep the same color. Yeah, I did a red. Right, and so you'd say, okay, where is sine negative? So C, A, S, T. Well, I know sine and all of them are positive up here, so it can't be there. And sine is positive here. The other ones are negative. But that means it has to be these two here. So I draw my triangles in these two. But let's think about this for a second. So if I think about sine is opposite over hypotenuse, right? Maybe that'd be -1 over 1. So opposite over hypotenuse for a second here. And I look and I go, okay, there's my two little related acute angles or my little related reference angle, whatever you want to call it. I would go, okay, opposite over hypotenuse and opposite over hypotenuse, right? -1 over 1. Okay, but I want you to think for a second. If I make that a little right angle in there, let's actually go and draw this triangle. We could just draw it separately over here. So if you have like a side length of 1, and this is really like a side length of 1, whatever. We had other triangles where the two legs were 1 and 1, but there's like, looking at this then, right? If this is 1 here, right, the hypotenuse is supposed to be the longest. So a better like example of this, I need two things that are the same length. 1 second. I have knives, I have toilet paper. No, I have paper towel. Here we go. Flexing my paper towel supplies here as they're running quite low, as you can see. Okay, so these two things, pretend they're each 1 long or the same length. It doesn't really matter here, right? And so basically if we're looking, I'll try and orient them so they're the same. Oh yeah. Okay, they're kind of like the same. There's your 1 and 1-ish, right? So hopefully that makes a little bit of sense. So if these things are supposed to meet, like this angle up in here is supposed to be a right angle, right? You can kind of see that's supposed to be the right angle there, and they're both 1 long. Well, if they're 1 long, then they're the same length side by side, right? If I line these guys up perfectly like this, they'd be the same length. But as I extend this one out, there's no way that can be a right angle, right? The only way it can be a 90-degree angle across the top here is if it's like the same exact right beside each other, but that's not a triangle. It's only a triangle if I, other way, extend these guys out like this, but then you can see that they're no longer flat, right? As I extend it out, trying to hold this up, everything's backwards. for me here. But there's no way I can get that to be a 90-degree angle there if these are the same length. It's not possible. This is just going to be too short. It's not going to meet over here. It's going to be too flat like that as you extend out. But as they're like that, it's flat. But as we go down, right, it's not the same length. Hopefully that made a little bit of sense. But it's just not possible to make a triangle where one of the side lengths, right, is the exact same as one of the legs. The legs could each be 1, like these two here could each be 1 and 1 if they met at a 90-degree angle, right? Where do I have that? It's kind of like, oh, sorry, got to roll up my paper towel roll here. This could be the same length, 1 and 1, and then they could meet, right, at a 90 degrees, and it would come across like this. That's totally fine, 1 and 1, but you can't have my arm the same length as one of those. Like if the thing here, right, I don't always mess this up, but anyways, if that thing there was, the same length, there's no way that this could be, flat across like that. They'd have to be 1 and 1 to meet at that 90 degrees. So in this case, not going to happen. There's no triangle. So this is a special case, and that's where you need to kind of think about. It's a special, different case. It's not the exact same thing. And so what I would do here is instead I would go, okay, well, if this is a special case, let's see what happens. So I'm going to erase this. I'm going to do a little star for you guys here. Not possible to make a triangle. Like this. So what I would do then is I would write, okay, well, x is equal to sine inverse of -1. And if you look at that then, sine inverse of -1, you might get, I bet you we're going to get 90 degrees or negative 90 degrees. Let's find out here. So if I take my calculator and I go second sine of -1, I get, I don't know how well you guys can see that, let's let it focus, negative 90 degrees, right? I don't even know if that's big enough in that screen for me to show you guys that all the time. I don't know how worth it is, but it's going to tell me negative 90. Now remember, I'm going to erase those two triangles because they're not important. Remember we said it's not possible to make those triangles anyway, so I'm going to erase them. Now if I'm thinking about negative 90, remember our initial arm always starts here, and positive would work this way, but it's not positive that the answer is. It's telling us a negative angle, so heading this way. And this would be negative 90 degrees. Okay, so it's right on that negative y-axis, right? Bit different. Sorry, my arrow doesn't really look like it is, but pretend it's exactly on there. Now, when we give our answers here, because there's actually, remember, there's an infinite number of answers for all of these. We're typically just looking for 2, except this one's a bit strange because it's only going to give us 1, and I'm going to explain that in a second. But we want to give answers that are always between 0 and 360. 0 degrees and 360 degrees. So looking here, that's not a positive answer, right? You want to give it as a positive answer. So how do you do that? Remember, to get those angles that are the exact same, you just add 360 every time, right? So if we take negative 90 and add 360, or just go in the positive direction here, we just know that is 3/4 of a spin, so that's 270 degrees, right? 270 degrees. And that's what your first angle is. And you might be asking yourself, okay, like all of the other ones, Mr. Ellis told me, there's 2 angles, right? First and second, first and second, first and second. All of them should have 2 angles. Now, I had a couple people saying, I did the first 3, they were easy, that's great. Okay, good, but those are easy for a reason. They were warm-ups. You should try to do some of these other ones in here. Now, maybe this one was a bit easy too, but this one here required you to divide, right? This one had to be reciprocal, and so on like that. So things definitely changed a bit for you there. For sure. So anyways, follow my video if you needed some more help with that. But our answer is negative 270. Now remember, sine being negative would have to be in one of these 2 quadrants. So basically, it's saying sine, remember we said sine is y over r. Well, the only way that we're going to get a negative sign is if it's down, right? And we also talked about how it couldn't fall in these quadrants because we can't make it a triangle. So it's definitely not going to be up here, right? If we tried sine 90, if you try that in your calculator, it's actually going to tell you positive 1. Okay, sine 90 is positive 1. So there's actually only this one answer in here. It's the only one where I'm going to get a sign that is negative. Okay, it's a sign that is negative, and it'll be in there. Actually, if you're trying, it's kind of cool. If you try any sine of any degree, sine 1, sine 2, sine 180, sine 90, everything is actually between, all of your answers are between 1 and negative 1. Okay, and that's actually because, and if I show you here, maybe this will help some people out. It's kind of interesting, I think, at least. If I'm going to go up here and I was going to go and show you on Desmos, and I was to graph sine x. Now there's a couple things I need to change. Right now this calculator is in radians, and we talked about how it needs to be in degrees. Sorry, I just changed that to degrees. And I also need to change my scale on my x-axis to being between, let's just say it goes from negative 360. Oh, let's just go from 0, because you guys don't like negatives, to 360 in here, right? So you can actually see that as I look at the graph of sine, doesn't matter what my x value is. My x value could be 50 and all these different things. It only goes up to, this is a bad scale here, sorry, but it only goes up to 1 and negative 1. So it goes between negative 1 and 1. There's no way it can be any more than that. You can type in sine 3000, sine 3000, and 3000 is going to be way out here, right? But still, this graph continually goes between 1 and negative 1. So it will always give you an answer that is, of between those two values. And so if you're looking here, this is a good way to solve these things as well and understand, right? Normally I said to you guys, give me 2 answers between 0 and 360. So there's 0, there's 360. I should have at least 2 answers kind of thing that line up with this. Now, if we're looking, I could even give you another trick question. But basically, if we go like, okay, when is our y going to be equal to, and we tried a couple different things, right? Like opposite over hypotenuse. So like when is y equal 1 over square root 2? We've tried that. That was one of our special things here, right? And so you can see it's like, oh, it's at 45 and 135. So if I say, when is sine, this is the graph of sine, equal to 1 over root 2, you guys were able to solve for these 2 angles. That's really what you were doing here. Now, obviously, that's only between 0 and 360. And remember I said there's an infinite number of answers? Well, it does. If we keep looking, it happens 2 more times there, and then 2 more times. Like it's an infinite number of times. You're just solving for the first 2 answers here, right? And that's when you're looking here. Now, you might go, okay, well, Mr. Ellis, it's always, like if I look at this then, you should be able to add this as a scale here, y equals a, okay, b, c, d. Why is this not letting me do a scale? C. Okay, anyways, I was hoping that I could slide the thing up and down. But basically, if I was to take a flat line and draw it through anywhere on this graph, right, go through 2 points. Or as I go through here, right, I go through 2 points here. And it's only at the top, you can see right here, or at the very bottom, where if I drew that line that goes through 1 or negative 1, it's possible that we only get one answer. So if you see here, we see that like, okay, what do we want? We actually solve for sine equals to negative 1, right? Oh, sorry, y equals negative 1. You can see that the only time it intersects just once is at that 270, and that's what we just solved for. It only happens the one time. It doesn't go through another time over here. Yes, in another cycle between 0 and 360, or if we go negative, right, with our angles, it does intersect again. But to get those other ones, if I had 270 and I just subtract 360, or we add 360, we'll get to those next ones. So that's kind of why we just solved for those first ones between 0 and 360. I've just got somebody sent me a message in Teams here. So is this one of these special ones we would need to remember? Well, it's not necessarily special in fact that you just need to memorize it, but I would recommend it's something to be aware of. Like when you have sine or cos being equal to 1 or negative 1, there's maybe not always 2 answers. In fact, one of the trickier ones is if I say when does sine equals to 0, and you'd notice it would happen 1, 2, and 3 times actually. And that's because, remember, sine is y. So if we go to this little unit circle that I showed you guys back up in our special angles day, when is your y 0 on this thing? Well, the only time when you're looking any point around here that the y is 0 is here at 0 degrees and 360 degrees. So that's 2 answers. But also when you go all the way across to 180, y is still 0. So right, if I typed in sine 0, sine 180, or sine 360, it will all tell me 0, 0, 0. So that's the only one that has 3. That's a very specific one like that. But anyways, okay. Definitely a little bit more special in that sense. Sorry. So this one only has one answer. And then this one here, cos x equals 1. Again, same idea with the triangles. Like if I was to draw this out, and we draw when is cos positive, so C-A-S-T, like this, you would get, again, adjacent over hypotenuse, right? So 1 over 1. Hey, I remember that we can't have the side length the same as the hypotenuse, so it's not going to work. So what I would do is I would, again, say, okay, well, when does this happen? When do I get x equals to cos inverse of 1? And if I type that in there, I bet you it's going to tell us 0. Let's find out. Second cos of 0. Oh, sorry. I should be doing second cos of 1. I was like, why is it? Anyway, second cos of 1. My bad. Yeah. So it does tell us 0 as our answer there. I don't know if you guys can see that bottom bit there. I'm doing cos inverse of 1 is equal to 0. So I get 0. Perfect. Okay, well, remember initial arm and then 0 is, it hasn't moved anywhere. Okay, so definitely our first one is 0. But remember, we're looking for any other angle where that would be a similar idea between 0 and 360. Well, if we added 360 to this and go all the way around, it ends in the same spot, right? So actually that second angle there, 360, should work as well. So if I type in, let's just clear everything here. If I type in cos 0, cos 0, yes, it's equal to 1 like we talked about, right? That's our first answer there. Let me angle that a little better for you. And then if I type in what I said was cos 360, that is also equal to 1, right? Both those suckers, both equal to 1 there. So we've got our 2 answers there. And that makes sense. If you were to draw out your cos graph in Desmos, and I'm looking, okay, when is that y equal 1? Well, it happens at 0 and all the way out at 360. So those 2 angles in there. Makes sense. Okay. So those were our final 2 answers there. Those were specific ones. They're special. It's just when sine and cos were 1 or -1. Obviously, when tan was 1 or -1, that was a triangle where we do opposite over adjacent. So these side lengths are allowed to be 1 and 1, and that's fine. But this would be root 2 here, because that's our special triangle. Liam, you got to give me a more specific question than that. I don't know how to answer. I'm still confused. Basically, these ones, you just looked, they can't make a triangle. We talked about how, well, I knew I had to inverse cos because I couldn't make a triangle. So as soon as I knew I couldn't make a triangle, I was like, okay, well, let's see if we can get something else from that. Hugh, I already shared the answers with you. I just asked you to copy down these 2 right now. So I don't think I really need to share the whole page a second time. You can pause it on either of these or go back. should already have the answer day 2 practice in there. But these two, just take a screenshot if you need that. Because I don't want to send you guys 2 of the same thing. Print screen. Okay. Basically, we're going to do something a little different today. Unless there's any of those questions that I assigned on your class page that you guys wanted me to take up as well. Where was that? That was here. Was there any of these you wanted me to take up? Just wait a minute. Okay, I don't see anybody saying anything, so I'll just assume maybe, but maybe you guys need a minute to open up where your work was, so I'll just wait a second here. I'm going to refill my water. And then we'll rock and roll. I can probably take back my props for the angles there. Okay, Cam wants to see 2. All right. Oops, I forgot my textbook in my room. I'll be right back. Okay, it's page 304, number 2. Determine the value of theta to the nearest degree if theta is between 0 and 90. Okay, cool. So let's try that one out. I'll just do this in... I guess I'll just do this below, eh? So 5... Oops. 5 point... wait, why am I saying 5.4? We're doing page 304. Number 2. So it says determine the value. So let's just do like the first one here to start and see if you guys get it after that. So cotangent theta is equal to 0.8701. And it says that the angle is between 0 and 90. So really what this is saying is it wants an angle in the first quadrant only. And I know technically, like if we do this here, oh, sorry, I get random pop-ups. This is really, right, cotangent is the same thing as 1 over tan theta equals 0.8701. Coolio. And then if you were to exchange these things, right, if you bring the tan to the top, so 1 equals tan theta times 0.8701, and then tan theta, because we're trying to get theta by itself. That's the goal, right? Solve for theta. Theta equals 1 over 0.8701. And then I can get theta by saying theta equals tan inverse of 1 over 0.8701. Type that sucker in my calculator. Second tan of 1 divided by 0.8701. Enter. I get 48 point, okay, let's just call it 49 degrees. Okay, so I get theta equals 49 degrees. Now we could also find another spot where that was true, right? That just tells me that this angle in here, what is it again? 49 degrees, is the first one. It's the angle that is in that primary thing. And I know that was cool because that is tan, and tan is positive there. There's also another spot where tan is positive, right? If we wanted to come up with a second one, if you're doing cast rule, C-A-S-T, there would be another angle in this quadrant here where its little reference angle would also be 49, and so you just do 180 plus 49 to get another angle. But it's not asking for that in this question. It just says find one. That's enough for it. Don't know if that makes much sense. We could just do a second one, I guess, quickly. Let's just look at cosecant theta. B is cosecant theta equals 1.6406. And again, it wants one in that quadrant 1. So I would again say cosecant. Remember, it's dumb. It should be cos, but it's actually sine. So 1 over sine theta equals that 1.6406. And then you get your 1 over 1.6406 is sine theta, because you flip it. Then you get your theta equals sine inverse of that garbage. Let's just see if this all works out, because maybe this is where the error came in. Let's just see if it gives me an angle between 0 and 90. If not, we just have to use that angle to find our other one. So second sine of 1 divided by 1.6406. I get 37.5, let's call it 38 degrees. And that's in the first quadrant, so that's cool too. Again, if you're looking for a positive sign, this is like kind of like something sine 1 divided by something positive, right? Will be positive. So you're looking for signs either here or here. I know that looks like a C, but that should be S. I just did it really fast. That's ugly. Anyways. Yeah, you'd have your theta equals 38 degrees there as we solve that. Cool? Any other questions or comments about that? All right. Then what I want you to do is I want you to go to your notes, and I think I've sent you already 5.5. You could be using your textbook today as well, whatever, doesn't matter, because it's a pretty short lesson, but it's one of the more difficult concepts, and I think fun concepts from grade 11 math, but that's because I'm psychotic. If you go to, 5.5 trig identities, did I send you this yet? Like if I go to, who's my test subject? Noah here, unit 5, 5.5 identities. Yeah, for some reason it's like, underneath all these other ones, but you should have that there. Okay, somebody just sent me a message that says, can you please take up 9? So I'll take up 9 here, and then I'll just finish off, and we'll do that note there. Sorry, where is my... number 9 says, okay. We can do number 9. So it says the point -9,4 lies on the terminal arm. So the point -9,4 is somewhere over here, right? -9,4. I know that because it has a negative x value and a positive y value. So I know that the terminal arm with my really crappy sketch will be over there, right? So here's my initial arm. My terminal arm goes to the point -9,4, it says. So it's to sketch the principal angle. So this would be our principal angle. Remember, that's the first angle between 0 and 360, the first positive angle. So that would be it. We just sketched it. That's all we've done. B says, what is the value of the related acute angle beta to the nearest degree? Okay, so what you would do is you would draw this like a triangle to get that angle here. So I'd draw her out, and we're just looking for this little, it says acute reference angle. So I know that this side length is 4, and remember when we're trying to solve for the reference angle, yes, that's a -9, but we're just going to deal with it as positive because then it gives me the actual positive, nice angle we want in there. So think about this, it's opposite over adjacent. These are the two kinds we have, so that would be tan. So to get that little beta, I'm going to say tan of beta is equal to opposite over adjacent. And so we do beta equals tan inverse, so it's a really crappy beta, of 4/9. So you type that in your calculator, wherever the heck my calculator is. Second, tan of 4/9 gives me, I get 24. Okay, 23.96, so let's call it 24. So that is, so this is for part B, sorry, this is part A up here. That tells me this little guy in here is 24 degrees, and probably part C is what's the value of the principal angle. So what is this angle all the way around? They didn't name it, I don't think, but we'll just call it theta. Oh yeah, it says sketch it theta. So again, theta is going to be equal to, well, if we had a full, arch here, all the way around halfway would be 180 degrees, but we're 24 less than that, right? So it's 180 minus those 24 degrees from that reference angle, that beta. So when we do that, what is that, 156? 156 degrees. Now I rounded, maybe they kept their decimals in there. All right. I'll leave that up there for a sec, but we're going to go on to the identities here. As long as I've covered 9. What's the difference between the standard position and principal angle? Okay, so standard position is just a word for, this is where, like, standard position means it always starts here and goes to the terminal angle. The standard position doesn't necessarily have to be, positive or negative. It just means like that's how you set them up. So what does this textbook actually ask for? Does it say determine the principal angle? So it's in standard position. Position just means like where the arms are placed. Like you measure from the initial arm, which is always on the positive x-axis, to where it ends. But that standard position could have a million infinite different angles. The principal angle of it being in standard position is the first positive angle. So this guy here, from here to here, it's in standard position. And I could say it's equal to its principal angle, it's in standard position, but its principal angle is the first one, so 156. But that angle in standard position could also be 156 plus 360, plus another 360, plus another, whatever it would be. So there's an infinite number of measurements for an angle in standard position. But then there's, only several... there's only one answer for the principal angle. It's just the first positive angle. So hopefully that makes a little sense, Paul. Okay. So standard position is like, this is where it's, because sometimes like you measure like angles, like it's like, okay, so this angle here, beta, is not in standard position. That's like the little acute reference angle, right? It's like from here to here. But standard position is always starts here and ends wherever your terminal arm is. But that principal angle is always first positive angle to get to that terminal arm. So principal angle is a measurement. Standard position is a position. Okay. I wonder if we're good to move on. If I went to here. Okay, so no questions in a little bit. I don't know how delayed I am. I think I'm pretty well live. Almost, just a little behind it. So what is an identity? These are things we're going to be able to do today. So basically, an identity, it might look boring at the start. And kind of they like a little bit are boring. If you hate math already, you're going to hate these. But to me, they're really cool because they're more like puzzles. You don't have to actually like solve anything. It's more like using formulas and using puzzle pieces to change how something looks, to make it look like something else, like what we want it to look like, to try and prove two things are true. So we all know, I've kind of told you guys that like sine x equals the opposite over hypotenuse, right? And you're like, okay, I just believe that. But like, what if I just like, told you a bunch of other formulas here, like this one. If I just said cos x plus sine tan x equals 1 over cos x, you might be like, well, what the heck? No way. How does cos x plus something different equal 1 over cos? Like, that doesn't make it. But we're going to prove it's true. But I don't ask you to memorize this. I would never ask you to memorize this. What we do is every single time we try to replace things. Okay, sorry. I have to. Please tell Banta. Okay. No cap. Okay, I don't know how that relates here, but I like it. So, what is an identity? Basically, and you can type this out with me, an identity is an equation, because it has an equal sign, something that has an equal sign. Sign that we use puzzle pieces or basic formulas to prove is true. So basically what that means is you are taking formulas that we already know are true, easy little formulas, and then we're using those to prove other things, okay? And your basic math skills. But you don't have to do any solving. You actually don't even have to use degrees right now. We're not even putting in any angles. We're just using formulas with like x or theta in it. So what are some identities that we know are true? Well, there's a bunch of them here, and I'm going to go and explain a bit, and we already have some for sure. So if we look back in our notes, there's a few different categories, and I don't want to give you too many. There's more that you'll learn in grade 12. They do at identities again in grade 12. But there's more formulas. There's more you have to know. They're more difficult, obviously. So in grade 11, they're pretty easy. So I do have the textbook open just to remind myself not to give you too many puzzle pieces, to only give you the ones that you actually will need in grade 11. I could give you more, but it's just too much. So what are ones we already know? Well, if I see something like, for instance, okay, well I don't actually see, most of everything here is like sine x, cos x, tan x, so the primary ones, but there's all those secondary ones that we know are true as well, right? So remember, the formulas we know are true is secant x is the same thing, and maybe write these into your little box here, because this will be kind of like your page to look back on. Also, I would recommend, if you want, these are on page 309 of your textbook. okay? However, there's some in there that I'm going to say don't worry about. So I would actually recommend that you just copy the ones I'm giving you, because I personally think there's a couple in the textbook that are just like too much. It's just like too much work. If you were actually to solve these, like, you'd always be like flipping back. So I think in this case, less is more kind of thing. So we know secant x is 1 over cos x. We already knew that, right? That was something we've already learned. It's the reciprocal thing. We know cosecant x is equal to 1 over sine x. We know cotangent x is equal to 1 over tan x. Shebang. And then what I'm going to do actually is I'm going to draw, because I've done this before. I'll give you a second. Give me a thumbs up when you're ready to move on, just so I know some of you guys are still with me, because this is a pretty key part of the lesson to get all these down. Maybe just, even if I know you probably already have these down, it wasn't a lot to write, but can you just give me a thumbs up that you're still with me in the chat? See how delayed I am too. Ty's giving me a thumbs up. Liam, Daniel, awesome. Jerry gives me a cat box because he can't follow instructions. Jerry. Okay, so that's 4 of you. I like that. Cam also. Logan dabs. Y'all just got the glasses. Paul's thumbs up. Perfect. 3, 4, 5, 6, 7, 8 of you. 9 of you. Hey, bat and peace, bro. All right, so there's like 10 of us here. That's decent. Kyle's giving me a thumbs up. He's alive. Thank you, Kyle. Thank you. Thank you. Some of you are watching Frozen 2 on Disney Plus right now. Bassett's alive. Good, good, good. Okay. Please stay with me for this part. This is the beauty part. I could just straight up give you the formulas, but Izzy's good too. Awesome, awesome. But I think it's important to kind of know where they come from a little bit. So I'm going to explain that. So if we go over here to the side, you can choose to write this down or not. If you're a memorizing person, then that's great. But if you like to understand, then maybe this is better for you. So remember, if I have like a Cartesian plane, thinking about the cast rule, thinking about all that other garbage for a second here, and we were to, have some sort of angle, and we're thinking about any point on there. Remember what I did before is I gave you guys the unit circle, so that way the hypotenuse was always 1. So if we do any, right, if you have your initial arm out here, and then you go to any angle up here, right, maybe this one's 45 degrees, whatever it would be, well, your hypotenuse is 1, right? If the side length of this circle, the radius of the circle is 1, well then all of these points out here, right? This is the point 1, 0. This is the point 0, 1, -1, 0, and down here is 0, -1. But if that length is 1 here, and this is the point, because we're looking at the point where it meets along the edge as it goes around. This would be the point x, y, and then we have this length would be x, this length would be the y value there. And this is something we looked at before, right, when we were solving for the little angles, drawing the triangles, all that sort of thing. Remember, for your angle in here, we talked about sine being your opposite over hypotenuse, right? So sine of that angle is opposite over hypotenuse. So sine was equal to y over 1. I guess I could write over 1. Cos of that angle was just equal to, right, x over 1. And tan of that angle was equal to y over x, because we had opposite over adjacent. So if you can take that triangle, right, if I just make a radius of 1, this is going to help us come up with a couple other formulas that are super important. So here would be the first one. I'm just going to let you guys get that down. I'll just give you a minute because I know some of us are a little behind. And once you get that down, I will rock and roll and show you how we come up with a couple more of these. So really here, x over 1 just can be written as x, right? If I erase this other side, and this can just be written as y. So here's a new formula for you. If we have sine is y and cos is x, right? Sine is y and cos is x. Well, then wouldn't tan, if tan theta is y over x, can't we just replace the y with sine theta? Because sine theta is y, right? We just learned that right here. So sine theta. And can we replace x with cos theta? Right? So what is tan of the angle is equal to sine of the angle over cos of the angle. Oh, sorry, I missed it there. So does that work? Well, let's check it in our calculators, right? If I type in something like, oopsies, my calculator. So let's do 45 degrees. So I'm going to do, oopsies, clear, tan 45. Okay, tan 45 is 1. Okay, so what I'm going to do is I'm going to type in sine 45 divided by cos 45. Also equals to 1. Right? So both of those, tan and sine of the angle divided by cos of the angle, they're the exact same thing. And I know that's not a very good proof, but that diagram we just did is the proof. We've looked at, oh, sine was the same as y, cos is the same as x. So tan of the angle is sine over cos. So let's add that to our chart. Instead of theta, I'm just going to write x. It doesn't really matter. Just think of it as the missing angle. It's the variable there. So tan of your angle is equal to sine over cos. And I could replace them. I don't know. Did I do thetas down here? No, I did x's down here. That's why I'll keep it as x there. So it could be tan thetas, sine over cos, whatever it is. It's tan of something equals sine of that thing over cos of that thing. So you're adding that on there as well. Okay. That also would mean if we have cotangent here. Think about cotangent for a second. Remember, that's the flip of tan, the reciprocal of tan. Well, that means we could short form it. This is one that I don't really think you need to have in your tool bank so much, but it is important. Cotangent would just be the flip of that then, right? You could just take an additional step, but it's really just cos x over sine x then, because we know that cotangent, right, is the reciprocal of tan. So if tan is sine over cos, cotangent is the flip. It's cos over sine. Okay, and then one more formula that I'm going to give you here. And then that's it. One more formula. So this next formula is if you look at this triangle, remembering that this is a right-angled triangle, I know based on the, let's write it down here, Pythagorean theorem, that we would have our hypotenuse squared, like c squared is equal to a squared plus b squared, right? The hypotenuse squared, so 1 squared is equal to x squared plus y squared. I think we could probably all agree with that. So 1 squared is equal to x squared plus y squared. Now that's really the same thing as 1, right? 1 squared is 1. And remember, x was, if you look back up here, x we said is cos, right? It's cos. So this is cos theta squared plus y was, if you look back here, right? Y is sine. So plus sine theta squared. Oops, sorry, you can't see what I'm doing. Now, typically the way to write these normally you don't have to write, like people are like, oh man, like I hate having to write out the brackets every time. So what people do is instead, the typical way of writing this is they write cos squared theta, and that's the exact, oh, whoa. Plus sine squared theta. And those are the exact same thing. It's just a different way of writing it that people, I guess, tend to prefer. So that's one formula, and that was the other one that we dealt with too. So we have 1 is equal to cos squared theta plus sine squared theta, and that came from our Pythagorean theorem. Cos squared theta plus sine squared theta. Okay, so I would write 1, oopsies, let's write it in black. 1, okay. Cos squared x plus sine squared x, like that. So those 1, 2, 3, 4, 5, 6 formulas are really the ones we need. Now you might be looking in your textbook right now, and you might notice there is, let's see if I can show you without screwing this up, those other ones in there underneath sine squared plus cos squared equals 1. You see the 1 plus tan squared is his secant squared, the 1 plus cotangent squared. Okay, those basically are just overly complicated. They don't help you at all, I promise. They might save you one step, but having to like know, I'm not asking you to memorize, but having to know all these other formulas, it just makes your life easier when you don't have to have all those other things in there. So that is basically the summary of our puzzle pieces. Now, I will say on the side here, I would just add maybe just a little bubble, just so you guys know this is true. Like if I have something where I see secant squared x, well, really secant squared is, if I know secant was 1 over cos, then I know secant squared is 1 over cos squared. And that works for any of those, right? It works for any of these here. And then if I know, like if there's something weird, I don't know why, maybe, I don't think you guys are going to have this, but if you had somehow like cos of 2x, like there's something inside, right? Or let's go secant 2x or something like that. I don't know. Secant 2x, that's really like, okay, we should probably do the other one, cosecant, something like that. That's 1 over sine, right? So that's really the same thing as 1 over sine 2x. So those things can still be applied if it looks a little bit different. Like the rules still apply, but these are your basic rules in here. Okay, these ones here are the important, and I call them puzzle pieces because basically you use them to solve the puzzles. Okay. So, when you're solving identities, and I'm going to scroll down in a second here, what I do, okay, is I think it's really important, and you can see on your left side here, and it's not that I think this way, it's because the logic makes sense. You need to separate the left side and the right side. And I know we've done this maybe once or twice earlier in the year. I remember explaining that. Remember I was like, okay, like you can't just assume two things are true. You have to separate them and prove they're true, like individually, and once you prove that they are the exact same, then that works. We talked about the logic where if I want to prove this is true, you don't just throw in x is 0, because that just proved one thing is true, right? It's like saying, you know, me and Ben Whitfield are the same because we have the same color of eyes. I don't know what we have in common. Same shoe size? I'm not sure. But that doesn't mean we're the same. That's just one thing, right? So you can't just show one x value. And so what you need to do is you need to separate these things into a left side, cos x plus sin x tan x, and a right side like this. You're going to work your magic on either side here, and once they look the same, then you finish with therefore left side equals right side. So my bigger trick, even than these lists, I've come to the realization that since making this, I think I made this sheet 2 years ago when I first started at Great Lakes, but a better way of solving these things and a more simple way for students to understand is it says work the bigger side. Yes. So this is the bigger side. So you'd typically start here. It doesn't mean you can't work on this side, but it just means that working on this side is typically a little bit easier. So I work the bigger side. You can factor it somehow. You can maybe use algebra. You can use the identities that you know up here that are true, basically to get to what you want. And that would be lovely. And so we're going to show you that in a second. But the bigger trick that I want to add in here, maybe do a little red, because you don't have to do it. But the bonus tip is change everything to sine / cos first. So that means, oh, sorry, you guys can't see that. Get rid of tan. Get rid of cotangent, secant, cosecant. If you can get everything in sine and cos, then that's way better, because then you can use this formula, which is the best formula. And I know you might think it's dumb, but this formula is like the most OP formula. It crushes all other formulas. And most formulas, you can notice, have something with sine and cos in it, right? They're all including sine or cos, except for this one here, but really cotangent is this anyways, so whatever. I almost would never use this. I would almost always say cotangent. Oh, I know that's cos over sine. Okay? You can use them. It's fine. But just basically I use 1, 2, 3, 4, 5. Because I change everything. Secant, cosecant, tan, cotangent. I change all 4 of these into something with sine and cos. And then I use this one to solve the rest. So let's see how we can do this. I'm going to change tan, like I follow in my instructions here. I'm going to change tan to, if we look at our formulas, right? Tan is sine over cos. So I'm going to use something I know to try and prove this is true, because we've already proved that tan is sine over cos. Sorry, I need to plug my pen in. We're back. So I write, okay, well this equals cos x plus sine x. And then I know tan is sine x over cos x. That's all I've changed so far. Cool. And then I go, okay, well now what? Now I've done everything to sine and cos. I need to end up somehow. I'm still going to work my magic here, but I want to end up as 1 over cos x. So let's see what's going to happen. So I'm going to have cos x plus sine squared x over cos x. Okay, you might go, well, that's weird. Well, sine squared x over cos x, here's what I would do with that now. Well, this is the reason that this formula right here is the best formula. So I look at this and I go, okay, I have 1 equals cos squared x plus sine squared x. And down here, I've got this risky, so I'm going to write this out. 1 equals cos squared x plus sine squared x. And I think I need to basically somehow in the end, right, get only cos x. So I shouldn't have sine x. Like sine squared over whatever, I could probably eliminate these things here. Or coses, if I have multiple coses, we can maybe get it down. So I really just want that sine to be somehow looking like a cos. So what I would do is I'm going to say, okay, well my sine squared x is going to be equal to, I'm going to just take that cos squared x and bring it across. So 1 minus cos squared x. And now what I have is cos x plus 1 minus cos squared x, right, over cos x. Sorry, you can't see again. We're going to pause there for a second. So all I've done is I've changed sine squared x to 1 minus cos squared x. I used that magic formula here. I took this one, I said, okay, I just want sine squared x. So I moved the cos squared across. So 1 minus cos squared. And we're almost done. So what you need to do at this stage is you need to have, in general, I need to make this pen a little bit smaller, sorry. You're going to have, this is equal to cos x plus 1 over cos x, right? I'm just going to take the cos x and divide it by both of these terms. So minus cos squared x over cos x. Okay, well, cos squared x over cos x, that little bit in there, that's just like x squared over x kind of deal, right? It's just x. It's just like you had cos squared over cos. You're just getting rid of one of the coses. Really cos squared x, right? Let's just do a little side step over here again. Cos squared x is cos x times cos x. It's just 2 cos x's. And it's all over cos x, right? So you just cross one of them out and you just be left with cos x. So what do we have? We have cos x plus 1 over cos x, but it's cos x minus cos x. So what are we left with? Just 1 over cos x. And if you look here, that side is equal to that side. So to finish it off, all you need to say is 3 dots. Therefore, the left side is equal to the right side. I'll just do one more example with you guys in a second here. I'm just going to let you finish getting that down. But that is always what you need to finish with. Okay, so I think we're probably okay. Here, this one, again, if I was to solve this, I go left side equals sine x plus cos x squared. My right side equals 1 plus 2 sine x cos x. Okay, and so in this stage here, I like to change everything to sine and cos, but we've already got everything in terms of sine and cos. So that doesn't really work. So what you need to do next, I'm just going to make this a little bit thinner again, is go, okay, deal with the more complicated side. And that's kind of dependent here, but I would say this side here, the sine x plus cos x squared is the more complicated side. And remember, that's not just because there's a plus in there, you can't just do that. It's only when you have multiplied. So what you need to do is sine x plus cos x times sine x plus cos x. And remember, now that we have this, now you go sine x times sine x is sine squared x. Sine x times cos x is plus, well, just sine x cos x. That's cool. Cos x times sine x is again, well, I could write cos x sine x, but that's the same thing as sine x cos x. And then our last one would be cos x times cos x, so plus cos squared x. So all we've done is sine times sine is sine squared. Sine times cos is, well, sine times cos. And then cos times sine was, well, again, cos times sine or sine times cos. I just wrote them as the same because we're going to put those together in a second. And then cos times cos is cos squared. So what you should know is that these things are the exact same. So I have 1 and 1. So in total, I have 2 of those, right? So what I would do is I would write this as sine squared x plus 2 of these sine x cos x's plus your cos squared x. And then we're almost done. The last little tidbit I would look at, so this is 1 and 1 makes 2, right? 2 of those. Now I would look at sine squared x plus cos squared x, and we should remember the identity sine squared x plus cos squared x equals to 1. So that's just going to be equal to, in the end, 1 plus your 2 sine x cos x. And you finish it with, therefore, left side equals right side. Okay, so me doing this lesson today was 1,000% useless. I probably could have stopped with one identity, but I wanted to show you guys, this is how we do the rearranging up here. And then this one, maybe you have to expand some brackets. Maybe you have to work some things out, simplify, deal with things like that. There's 100 different little tricks that you're going to have to learn. Maybe not 100, that's excessive. There's 100 in grade 12. But basically everything I've taught you today is useless if you just decide, I understand. I saw him do it. I know how the rules work. I don't give a crap how the rules work. They work. You should follow the rules. You should follow these steps. But if you guys just look at this lesson today and go, sweet, that's enough, then you're toast. I could give you like 10 identities tomorrow and you'd get 0. I can almost guarantee it. That's not an insult. That's just like, I'm going to give you things where there's a little trick or something you have to think through that is going to be difficult, and you will have no idea where that's going to come from, and you'll have never seen anything like that before. So of all the days to say homework is the most important, this is the day for that. It's days to practice identities. Now, it's already 11:30. So I think what I'm going to do is, because I've never taught identities and not spent 2 days on it. Tomorrow we're going to work through identities, and I'm probably going to start off class. Maybe we'll meet together again and do something, and maybe I'll take up some identities that were difficult. But in general, these identities, like if you don't practice them, you are so toast. They're tricky. They're not easy to solve. And I would say this is that often I get, especially in class, this is the day where I have the most people come up to me and be like, oh, this one doesn't work. Or they get frustrated and they give up really easy. And I find that's true with a lot of different questions, right? We just you try start, you're like, I don't know how to do it, and you just give up. If that's your goal, if you're going to be somebody that gives up really easy, it's going to be really, really difficult for you to do well. So this is a really good test of your resiliency in order to go, I can't figure it out. Well, then what you need to do is, if you can't do it, erase, start on the other side, or come back to it. Some of these, I've had some of these before, less so in grade 11, more so in grade 12, that you might spend, your steps are a page long. They just keep going. And then it's like, crap, I'm back to where I started, because you just changed things so much. And that's going to happen at the start. It's not going to be till the end where you can kind of see where to go. How did I know to do this? Well, it's because I've done stuff like this before, and I could see that, 2 sine x cos x, that's going to come when we expand them out. I knew that was going to happen, right? Also, I knew sine x times sine x is sine squared x. That typically gets me to a 1. So that's a trick that I've learned from practice, right? Knowing that's probably the first step. Some of us might have started over here and said, this is 1 plus sine x cos x plus sine x cos x, or something like that. I don't know. Or maybe you changed 1 to sine squared x plus cos squared x and then tried to deal with it from there. There's 100,000 different ways of solving these. In infinite ways of solving these. So definitely not the easiest questions, but they're good to know. So let me see. Did I throw any homework on here? I believe I did not yet. There's only 5 minutes left. What I'm going to do, oopsies, Cortana says, while you were gone, I am going to, why is that all filled out? That doesn't need to be filled out. Give you, just for tonight, these 6. But try a couple of them, okay? Don't try a whole ton, because I'm going to give you tomorrow to try them as well. And I have more identities tomorrow as well. But we really should be spending that full class period tomorrow practicing these things, because they are not easy. There's lots of different tricks, as you can see here. How the heck is that one going to be equal to secant theta? Well, you're going to find out. So definitely through there. So I'm just going to send this to you guys right now. Try a few of them as you're going down. Remember, my trick is to change everything that's cotangent, tan, secant, all of those to sine and cos. So let me send this to you now. right, should be good. It's sending out. But anyways, unless there's any general questions, it's something that we just really need to get to and start practicing. Looking at these, actually probably, these ones are a little trickier. So for your first identity, maybe your first own identity, if we go to 5.5 for a second, it's just I find the textbook ones are like embarrassingly easy at some parts. If you want some easy ones to start, warm up would be page 310, number 5. That would be like some really easy ones to start, page 310, number 5. But if you feel comfortable with this, you're like, I want to dive right in, try these ones here. But you should be able to do those ones on page 310, number 5. Anyways, just try a few of these tonight, guys. And if you're able to rock and roll, that'd be fantastic. Cameron, if you're still there, I just saw the funniest post on our faculty group. A bunch of the teachers are like, does anyone understand Cameron's TikTok? I don't get it. So anyways, you've shown all of our age. I had to take a minute to understand it too. But it's a good hair joke, that's for sure. Okay, team, if that's it, you're free to go for lunch there then, so rock and roll. I will. I'm going to explain it to them. I'm definitely going to explain it to them. I was going to go and do that right now. I was going to be like, well, here's what it means. Because I don't know if they think it's like inappropriate or not. I'm not sure. So I was just going to explain because it's not. It's fine. Oh, no. No, you're good. You're so good. I'll go explain it. I thought it was so funny. I died. I needed that. Thank you, Cam. I haven't laughed that hard in a while. I needed that last few days for sure. Yeah, it's like clickbait, right? It's like, oh, he's going to watch this video on how to hair care. Ooh, what sign? It's like what you needed me for, something different. Yeah. That's good. Okay, homies. Thanks for coming to class today. Miss y'all. Talk to y'all later. Number 4 is actually easier than the others. Yeah, that's probably true, actually, Jer. That is probably true. Peace out, homies. Thanks, Daniel. See you, Liam.